When we were doing primitive functions yesterday, we only found we only integrated it and then we had plus c at the end. We didn't find what c was. Now that they've given you extra conditions, you can actually find what c is. So that's an extra condition and that's an extra condition. So given that f dash is equal to x cubed minus 2x squared plus 5 and f1 is equal to 4, find what fx is. So that's the derivative of fx, so we have to integrate that. So let's integrate it. Do you remember what to do when you integrate? What do you do to the power?
And 1.
Yeah, you up the power by 1 and then divide it by the same power. What about this one? What do we do to the power?
3.
Yeah, 3 and then divide it by 3. So you keep the constant with your x's. Plus 5 what? 5x plus
C.
Alright, so now what we're going to do here is we're going to substitute. This is your first line of working out. Second line of working out is we're going to substitute 1 for x to find c. So substituting 1 for x, we get 1 quarter minus 2/3 plus 5 plus c. And we know that f1 is equal to 4, so we know what c is. What's all this? What's all that? Use a calculator.
Oh, you mean answer?
Yes,
That's
just
a trick.
yeah.
That's like a trick question.
No, it's not a trick question. Just what's the answer to all that? What's 1 quarter minus 2/3 plus 5?
Equals. You don't mind.
I'm just gonna give you some take-up time.
Open mail and we can record and now it's answering the question.
Oh,
Doesn't matter.
my answer. 55.
55 on
Oh, crap.
On 12.
55 on 12. Alright, so we're gonna add that to 4. So therefore C equals.
Positive.
Oh, it's positive. Sorry. Then we subtract it from 4.
Oh, no, don't worry.
Subtract it from 4. We get
Negative 7 as well. 12.
negative 7 on
12.
7 on 12. Okay, so now that's what our c is, so we go back to our original function, and your final answer is going to be fx equals x to the power of 4 minus 2x cubed over 3 plus 5x minus 7 on 12. So we're going to replace the constant term with this value. So that's your final solution. So that's just the only extra step that you'll have to do. So you integrate first, then you substitute the values they give you to find C. So can we start question 2 now? Yeah, I'll give you a few moments to copy that down. You don't need writing time? Okay, we'll continue. Okay, let's do C. Alright, let's do question 2 then. So that's the derivative. The derivative dy dx equals 2 minus 6x. So what we want to do is we want to integrate it. So integrating 2 gives you 2x. Integrating 6 gives you 6x squared. 2. Just remember, it's always over the power plus c. So I'm just going to fix this up. 6 divided by 2 is 3, so instead of 6x squared, we have 3x squared plus c. So the next part is using that extra piece of information, we're going to solve for c. So we're going to substitute. So this quarter tells us when x equals minus 2, y equals 3. So I'm going to substitute x equals minus 2 and y equals 3 to solve for it. So,
Yeah, but they go on hold.
alright, so we're substituting it in. So it's 3 equals 2 times minus 2 minus 3 times minus 2 squared plus c. So I've got minus 4, minus 12, plus c. So to solve for c, I just took the negative 16 to the other side, so c is 19. So the equation of the curve is therefore 2x minus 3x squared plus 19. So instead of the c, because we were given values, we substitute the c for 19. So you should be able to do every question in that exercise now. I'll give you one more.
You used really hard on this.
11. I'm using an older textbook, so I'm hoping that 11 looks like this. Is that what 11 looks like? 12x plus 6?
Yeah.
12x plus 6?
Yeah.
Okay.
Don't move. Yeah, right? Love it.
Oh wow.
Thank you.
Slowly move.
Don't move.
Robert's.
It's like a caged animal.
Thank you.
It's just going to be a camera people.
So find the equation of the curve. Okay, so second derivative means what do we have to do to second derivative to reverse it?
Second derivative.
Yeah, so we're going to integrate twice. And so when we integrate this once, so that's our second derivative. When we integrate it once, we only get our first derivative. So our first derivative is going to be dy dx. So let's integrate this. This will be 12x what? Squared on 2 plus 6x plus c. So don't forget that every time we integrate, we add the constant. So just fixing this up, dy dx
6x squared.
equals 6x squared plus 6x plus c. So we know that, so this is information, we know that at the first derivative equals 1 at minus x minus 2. So we substitute, so we sub dy dx equals what? Was it minus 1 or 1? No, 1. No, we're substituting this dy dx equals 1, sub y to dy dx equals 1, x equals negative 1, and y equals negative 2. So we're distinguishing between the derivative and the x and y coordinate. So that's the x coordinate and that's the y coordinate. So substituting this in, we get 1 equals 6 times negative 1 squared plus 6 times negative 1 plus c. So we didn't really need to use the y in that case. So 1 equals 6 minus 6 plus c, therefore c equals 1. But we're not finished just yet because we're only substituting this c to 1. So we go back to our first derivative. So our first derivative was 6x squared plus 6x. So instead of c, we call it 1. What we should have done was should have called this c1. Should have called this c1 because we're going to actually have to integrate again. So we're integrating again. I'll just write the lines I'm working out. So from the 8th line, we're integrating this. So integrating this, 6x what? 6x cubed over 3 plus 6x squared over 2 plus 1x, yeah, plus what else?
Plus C.
C, we'll call it C2. So our second constant. So just fixing this up. So 6 divided by 3 is 2. So 2x cubed plus 3x squared plus x plus C2. So now we have to solve for C2. So what information would we use? Would we use this one? No, so we'll use this one, yeah. The reason why we don't use this information is because we don't have dy dx, but we do have x and we do have y. So we're going to substitute. So we're subbing x equals -1 and y equals -2. So -2 equals to 2 times -1 cubed plus 3 times -1 squared plus -1 plus C2. Where did I say that second? So that stays as -2, that stays as, that becomes -2, this one becomes 3, this one stays as -1 plus C2. We'll add all these together.
0.
Oh, is it 0? Oh, that's easy then. Therefore, C2 must be what? C2 is -2, which means we can go back to our original equation, which is this one here, our original equation, and we substitute -2 for C2. So your final solution is y equals 2x cubed plus 3x squared plus x, not plus, minus 2.
Sounds good.
Yeah, that's it. That should be your final solution.